Hi, this is Tim from CADWorks in Denmark. Now I'm going to machine this part file because there was a video where someone was struggling quite a bit programming this. This is created in Inch and I would like to work in part, but this also gives me an idea or an opportunity to show how we can actually create a part in a part model to work with. This is very useful if you don't want to make any changes to your design model, then you can either use this approach or obviously use an assembly for your machining. But in this case, I'm just going to insert the part file itself, and I'm actually just going to bring in the part file on its own. I don't really care for anything else. So here we have it, and the machining of this one should apparently be near to impossible using SOLIDWORKS CAM and CAMWorks. I do disagree. So the first thing I want to do is I want to machine from this side, because we want to drill all of these holes that are coming through. They are kind of crazy. I don't think you would create holes like that in a real part. But anyway, for that we go into the CAMWorks feature tree. We define our stock. And I'm just going to use a bit of stock offsets, like 2 millimeters. So 2 millimeters on all sides like that, and then OK. Now we can obviously define the coordinate system. This is actually not really doing anything. Yeah, it is, but not what you would think. This is primarily for the indexing, the rotating point of your 5 or 4 axis machine. But of course, if we only have one mill part setup, then we are going to use this one for the machining direction. So now we have that. So this face would be in perfect good shape. I will start by inserting a mill part setup. I'm going to do face and I'm going to do perimeter. Now notice I'm not using any of these extract machinable features and generate operation plan. In fact, I have even removed them from my CAMWorks toolbar. Reason for this is this causes a lot of confusion, especially for new users, where you would not really understand what is going on. So if I were to run recognize features on this mill part setups, now I'm just checking in that direction. We can see that I find a face, a perimeter, these were already inserted, and then I find hole, and another hole group. Now if I run the feature recognition again, it will not find anything, obviously. If I throw let's just throw a hole to the recycle bin, then if I right click and recognize features, I will not find that hole again because it is in my recycle bin. If I remove it from the recycle bin, I'm telling CAMWorks that, hey, now you can find this hole again and add it to your features list. And this is causing quite a bit of issues for especially new users when you are using this extract machinable features and you have something you throw out and then empty the recycle bin, because why did it recreate everything again, right? So now we have everything defined. Actually, let's do something with these holes. I am going to go to parameters and I'm going to tell that this is going to be a thread. It is going to be a, let's just filter on the thread diameter. So we see 6 millimeter. Okay, so that is ID number 1 or line number 30. Perfect. So let's do that for these other ones as well. So we do parameters, we do thread, library, this one. And let's do that for the last one as well. So parameters, it's going to be thread, library, number 30, and OK. So now we can create this operation plan. And this is what I would do in many cases. But you can obviously go in and say, well, for the face feature, I want to do a 2.5 axis mill operation. I want to do face mill. With that selected, you will be prompted to select the tool and you can say OK. So you can drive this the old way in quotation, where you just define the geometry you want to work against, and then you select what type of operation you want and what type of tool you want. So you have all the control at your hands in that case. But let's just OK that one, and let's create for all of these. Now I already have a feature on operation for this feature, I should say. So when I press this one, it is going to ask me, what do you want to do? Do you want to update, or do you want to regenerate? If I regenerate, I'm going to delete what is already in the operations and then pull data directly from the TechDB. If I do not want to delete my existing operations, I want to do an update. In this case, I'm just going to regenerate. Let's create some toolpath. And I can see that we have some drill, center drill, drill, center drill. Let's clean that up just a bit by combining operations, rough, contour drill, center drill, thread. Yeah, we don't have that. We have tap. I think that's it. Okay. And that will clean up the tree quite okay. So that is the first side of this setup taken care of. Let's move to this side. Now, I noticed that here we want to bridge a gap. So we need to go from this line to this line. And I could probably extend a toolpath by X amount of inches or millimeters. But if for any reason the design model would then change, then the toolpath would not update. And my toolpath would then be either way too long or way too short. So a better way of doing that is to create a sketch and just make this associative by connecting the dots, basically, right? So now we have a line, and regardless if this part file will shrink or extend in width, then this sketch line is going to just follow along and everything will be perfectly fine. So now I have that taken care of. And another way to look at this is when you have inserted your design part into this CAM part, then you can do whatever you want because the design model is not going to be altered in any way. So I'm going to create a new mill part setup. So I will be on the feature tree, right click stock manager, mill part setup. Coming in from this direction, we can see the arrow. I'm going to do a face mill and we're going to hit OK. Now, with that taken care of, I think it's time to machine this area. And actually, if I select a surface, I can go and right click and do recognize local features. Now, I'm not going to use this approach. That didn't find anything. Great. Let's see. So I'm just going to have a look at my options. In my mill features, this is why I need to have tapered and filleted. In fact, when I'm in here, I can see faces added. I really don't want to automatically find this face and part perimeter. I would never want to find automatically. I would do that guided in any way. While we are in here, I think you can toggle these on and off as you like, but there is one that I really like and recommend. That is the collapse operation dialog on preview. Remove that tick mark, and that will make life more easy on you, I think, at least. And also, while we are in here, make sure you go to the update and that your 3-axis toolpath is defined as advanced method. So that should be it. Anyway, now if I select this face now I added this tapered and filleted, so recognize local features, and it should find one feature, and it did. And we can see that this is going to find an irregular slot, and you can actually see that it's flowing quite well, following that wall. Now, it is not bridging this edge, and I really don't like that it doesn't. So I'm just going to delete this one again. So off you go. And I'm just going to keep this in my recycle bin because I don't want this to be recreated by mistake if I do any rebuilds later on. So manually, I'm right-clicking on this mill part setup, 2.5-axis feature for that type. That would be, that's actually a slot or a corner slot, same thing. And I normally say always select faces and try to limit selecting edges. But in this case, we really don't have any option. I need to select these model edges. And you can actually see that we are drawing like this rectangle, and we are closing this loop. So now we have the area that we want to machine. For the end condition, I want to go up to that surface, and notice that everything is now in dashed line, meaning that we have air segment. That means that the tool can cross freely all over, and I definitely want to prevent the tool from getting into this area. So I need to close this line, and we can do that by edit feature profiles, and then just highlight and find the line in question. So that would be this guy. Close that, and OK. And essentially, I just want to rough this one out, so I'm going to select rough mill. That's perfectly fine. Nothing more needed. I also need to machine this slope. So again, I'm just going to use the same line. That will, in this case, then be a open profile. And I realize that this is stuff you need to know to understand how it's working. But I mean, you only learn by learning. So now we have the wall defined. This is the wall that I want to machine, but I want to place this. I want to lie this plane down on this plane, on this surface. And to do that, we can go in and evaluate, measure, and kindly ask SOLIDWORKS to return. Make sure we have nothing selected. Return the angle, and that is 51.72. Perfect. And we can then dump that in here. Paste, and then click in a gray area, and then you will see that the top line now aligns perfectly with the model geometry. So that is quite easy, I would say. At this point, we are now ready to machine the internal pocket. So let's machine that as well. So I'm just building the features at this point. I'm not doing any operations at all. The internal is obviously a pocket. So we are going to use open chain again, and I'm just going to select on the model walls. So not the edges, but on the faces. Oftentimes you'll find that selecting faces is a more robust way of defining your geometry. So this is what we are going to do. And I'm just going to rotate this around so we find what we need. And one more. And we're always closing this loop, so we actually don't need to select the final edge. We can see that we have one valid profile. Okay, end condition will be to the bottom of this one. So now we can see the area that we are trying to machine. Let's try and avoid this one, so we can go to the island. I clicked crazy place, I'm not sure what happened. Let's select that one. So we can see that now we have selected island, and that is this area. And that should be perfectly fine. Now at this point, we can go one by one, right click, and then insert rough mill contour and so on. But in fact, I'm not going to do too much for this. I'm just going to run the strategies from the TechDB, then generate the toolpath, and then have a look. I can see that I have a rough mill with a 6mm tool, and that is definitely not what we want. So let me go in here, find this rough mill, and maybe move that to my 16mm flat end. It's going to update the toolpath very quickly, and I also want to make sure that we machine the top face over here. So let's just go back to the rough mill, and I'm going to make a few adjustments to this one. I don't want to do a finish pass on the bottom. I mean, I could, but I do want to machine either distance along or exact, and then island top. Both of these should generate a toolpath at this layer. So let's see. Yeah, we got that, and everything's good. So perfectly fine. Now that is basically it. I mean, we have programmed this part file, and let's just run through the simulator and see what we got, and then adjust a few toolpaths as we need. So starting from this side, let's go next operation. We face mill, machine the perimeter, we drill with a spot drill, a true drill, and a tap drill. Then we flip it over, And I can see that my 0 point is actually located incorrectly, and let me cover that as well for you guys. Now this was the face mill, then we are going to rough away this area. Looking good. That was our contour mill, definitely need to work on the step overs, and then we rough out the internal, we rest machine, and we finish pass, and I can see that I need to dive a bit further down with my finish pass as well. But that's pretty much it. So let's start by checking this one and just making sure that we have a better step over for this contour mill. I don't know how much we want to do in step downs, but I do know that we can just swing it. I mean, we don't have to be very accurate. So now we have this as our strategy, looking much better. And then we had this contour mill. Let's just make sure that let me just make sure that this rough mill actually is machining what I want to. Yeah, that looks good. So this one needs to be machining to the depth. Okay. So for this one we can just add some flat area and machine the bottom of this one. It doesn't really matter too much. Let's see what we get. So I'm just changing these parameters, distance along, and then we can see that we are machining pretty good. That's okay. Now, one thing we can do additionally is we can machine these ones to be much more perfect. And now they are not perfect at this point, but we can go in and create a new, and this time it's going to be a multi-feature strategy, because this is actually more into a 3D toolpath. I'm just going to pick on all of these surfaces, and the reason being is when I'm running with a ball mill, I probably need to do some offsets anyway on these surfaces to get a good blend. But let's just add these. Now for strategy, we can pick depending on your product, if it's SOLIDWORKS CAM or if it's CAMWorks. We can either do C level or pattern project. So I'm just going to pick the pattern project for this one. And I am going to select a smaller, let's do 4mm ball nose. That's probably okay. And it should open the dialog for me. And opening the dialog depends actually on a setting, and I can show that in a second as well. Let's extend this by, I don't know, 1mm tangent extension. Let's go percent, and I don't know, 2% of the tool. And let's just take a look at my contain area. I'm not going to use any contain area. Instead, I'm going to use avoid features, and I'm just going to select everything with the exception of the 3 faces that I want to machine. So that is like inverted selection, you could say. And I guess that should be just fine for the initial toolpath calculation at least. So we can see that we are not doing too bad. Now we are running in the wrong direction, I would say. So let's just rotate this by 90 and let's just crank this up, let's say 6% instead. And I can also see that we have like ramp lead-ins, so we can do a plunge. If you want to, you can even change these to smaller values. Everything is up for editing the properties, so everything should be perfectly fine at this point. Very good. Let's take a look. Now we have these toolpath, and I know that this one we might want to do a bit of offset to make sure that we actually have anything to machine, right? So for the rough mill, and it is slightly slow when I'm running the screen recorder as well. So let's just give this, I don't know, 0.5mm. That would be probably okay. And let's do the same over here like that. So now we have some room left to play. We have some material to cut with the pattern project. Let's do a contour mill as well, and then do some offsets or allowance on these passes as well. So that would be 0.5. I think I have that. Nope, 0.5. And that should be it, I guess. Allowance 0.5. We need 0.5. Okay. Everything is now good, and if I run the simulate, yeah, actually it's not good because I need to move the 0 point as we discussed. So I'm just going to double click the mill part setup under the operations tab. So where you see all your rough and contour, double click the mill part setup here, and then pick an entity, pick a point. And now this dialog is slightly in the way, but now you can see that the X is pointing the wrong direction. We can then go for the axis, select the entity, say run the X this way. Again, I'm selecting a face. I could also have selected that face, or I could have selected the edge, but again, I'm very much against selecting edges. I'd rather select faces, not sure why. So now it's going to recalculate everything, and that is perfectly fine because we want to calculate from this point, obviously. And with that, I think this part file has now been programmed quite okay. Let's see. Next operation, run the face mill, the perimeter, spot drill, and a tab, and then we flip it over and run the face mill here, and then rough, contour, rough, semi rough. We need to move a bit further down, but we don't care at this point. And then we machine the surface with a ball mill. And of course, we can go in and change the step overs if needed. So that's it. I think I machined this one pretty well, I would say. Let's see what we have for. We do have a bit of material here, obviously, and down here, so that is to be expected. But in any case, we managed to machine this part file with, yeah, we didn't break too much sweat, I would say. When I was editing this video, I realized that I hadn't cut the contour too well, and I also skipped a setting in the pattern project. So let me go into the contour mill because we had a small leftover here that I definitely want to address. Now, in the video you just saw, I had bottom finish defined, and we actually don't need that. We can go in and calculate the correct depth of cut for these ones. Now, this is a inch part being machined in millimeters, so this is causing quite wild dimensions. But if I go back into the evaluate, select the measure, and then select this top face, and the first top, or the top of this this island, we can see that we have a dimension of 15.875. Now you need to crank up your precision in some of these cases, but we can just copy this one, and then we can actually say, well, first cut we don't care, and you do whatever you want. We want to have exact cut depth, and then say, well, for this one just insert that and divide by how many step downs you want. Maybe you want to have 7, and then just click outside. And when I do this, I tend to remove one digit. In this case, I'm just going to change the 8 to a 7 and then just preview. And this should give a toolpath very, very close to the top, so we are cutting this part like we want to. So that is the first part of it. Let me close this one. So actually, in that you already saw there was a trick. You can use mathematics in your dialogues. That's very good to know. You are in SOLIDWORKS, so obviously you probably knew that already, right? Now for the pattern project, we also had a small issue. I hadn't defined the last setting that I would like to have. Actually, 2 settings. When I do the geometry and I have this avoid defined, then we actually have a void allowance which defaults to 100 of a millimeter, and we just put that to 0. That is going to make sure that we are not going to stop short of anything. And other than that, the waterfall ends was also defined, and we don't want to waterfall ends in many cases, so we removed that tick mark. But other than that, I think everything would be perfectly valid in the video that you just saw. So with these few changes, if I run the CAMWorks simulate toolpath and then just run it through, I really don't care flipping it over. So now I can see everything has been machined, and we should be very, very good shape for the outcome of this part file. I would not hesitate running this on the machine. If I compare the design model to the machined model, we can see that everything is looking pretty decent. Obviously we have red gouges. That is the nature of cutting a thread. The tab is always bigger than the drill, so that is reported as a gouge. I'm not sure why CAM software is doing that. I think that is I have seen that in all the CAM software I'm working with. And if you want to change anything in regards of step over, you can obviously do that to get better surface finish, but I think everything is now perfectly fine. So that will be the conclusion. Thank you very much for watching.